Hi everyone, I am Mr. Prabhu R, Mathematics faculty in Kumudoti Residence Center School, Shikaripura. Today, again, I am continuing the first chapter contained the exercise 1.2 remaining problems. Let us start. Okay, what it says? Find the LCM and HCF of the following integers by applying the prime factorization method. Yesterday I shown how to solve the problems by using the prime factorization method. The same way, once again I will take the examples. Solution. So here numbers are given. Yesterday only we solved two positive integers. How to calculate the HCF and LCM by using prime factorization method, using only two positive integers. Now today take three positive integers. That is 26, 15 and 21. So first of all, express the given numbers into prime factors. Again, remember what do you mean by HCF and LCM? HCF means highest common factor. LCM means lowest common multiple. In which the factors, which is the highest factor, which is the lowest factor, will be considered to find the HCF and LCM. In case of HCF, what happened? The factors which contains the lowest power, we should consider lowest power. In case of LCM, what happened? We should consider the greatest powers of the factors. In the HCF, common primes highest power, lowest power, and here LCM, greatest power of the each prime factors. So that is why today we can continue. First express the given number into like this: 26, okay, and 15. And 21. Again, what do you mean with factors of this 26? Take 13. 13 into 2s are 13 2s are 26. Again, here 5 into 3. 5 3s are 15. 21. 7 into 3s are. Okay. So now consider their HCF. HCF of these three numbers. I already told the factors, the common primes which contains the lowest power, that is known as HCF. Here, consider which is the common prime number here. No one, because 3 here, 2 here only, 13 only one number, 5 is only one number, 7 is only one number. Otherwise, you can express these numbers into different factors also. Order may be changes. Yesterday I told that by using fundamental arithmetic. So on this also we can solve. So HCF, now consider there is no common factor. I mean there is no common prime factor in the given expressions or these numbers, so that there may be a one is, at least one is the HCF of the given positive integers. HCF become 1. Now what about LCM? Consider their highest power. I already told. Here 13 is a prime number, 2 is a prime number, 5, 3, 7, 3. All are primes. But here no one should be repeating. That's why it cannot be expressed in the terms of factors. So powers of factors. That is why we should write it again. And its order. First of all take 2. Only 1 is there. Next 3 is 1 power. Because it is also 1, it is also 1. So next into 5. Here order also consider. Take ascending order. And 7. And lastly 13. Each having their power should be 1. For LCM, we should consider the highest powers of the prime factors. Here 2 contains 1. 3, it should be here 1, here 1. Because these are the different numbers. That is why we can take any one of that factor. So 5 to the power of 1, 7 to the power of 1, 13 to the power of 1. So you can multiply all these numbers. 3 2s are 6 into 5, 7 5s are 35 into 30. Again, so 6 5s are 35, 3 6 3s are 18, 21 into 30. Therefore, multiply again. 35s are 65, 6 carry, 31s are 30, 36, 19, 1 carry, 32s are 26, 27. So therefore, LCM of these three integers, positive integers, is 2795. Like this, we can find out the HCF and LCM. So, in the same way, second one. Okay. Consider the numbers 70, 23 and 29. Here, we will express them in the same prime factors. 17, 23, 29. Look over here. 17. Already it is a prime number. What do you mean by prime number? Prime number is nothing but which is a natural number which is divisible by 1 and itself. So that is why 17 is a prime number. It is divisible by 1 and its factor is also 1. 23, it is also prime number, so that it can be expressed as 23 into 1. Okay, 23 into 1. Again, 29. Is there any factor? By use prime factorization method, he said there is nothing. Okay, so if you divide it by 2, it is not possible. If you divide it by 3, it is not a multiple of 3 because it is not divisible by 3. So there is, if small least prime numbers cannot divide these numbers, it means there is no common factors are here. Otherwise, there is nothing to express in the factors. That is why 29 itself and it is multiplied 1. 1 is a common factor for all. So what happened now? HCF of the given these three numbers is 1 again, because all numbers are different and their at least common factors of the containing power is 1. That is why 1 is common here. You can take 1 is a HCF as in your previous case. Now LCM, automatically you said that LCM means it is the greatest power of the prime factors. Here instead of the factors we should take their numbers directly because all are in the primes. 17, 23 into 29. You should multiply them and get the answer. Here I wrote multiply 7 is of 21, 2, 7 is of 14, 14 plus 16, 1, 3, 2, 1, 9, 3. Again, so this over 29, 29, 1, 1 8 carry, and 3 is 27, 35, 2 1s are 2, 9 2s are 18, 1 carry, 2 3s are 6, 7. So therefore your answer 3, 13, 11. So your answer now 11,330. Therefore LCM of these three positive integers is 11,339. So this is how to calculate by using here. We should not use the prime factorization because already you directly used the expressions like this because you know the factors. So suppose any prime numbers are given, at least HCF what happen? HCF will become 1. That is so now. Yesterday I solved this type of problem. Given that HCF is given and find the LCM. What we have to calculate here? HCF is given of the two positive integers. We have to calculate the LCM. So in order to find the LCM, first we write whatever they given. So HCF of 306 and 657. Okay, 657 is equal to none. Okay, find LCM. LCM is equal to question mark. So now consider A and B. These are any two positive. You know that the form, that is the product of HCF and LCM is equal to the product of integers. Product of two integers, that is positive integers were given. So that is why the product of HCF and LCM is equal to the product of the given two integers, positive integers. So I should write like this in the formal way. HCF into LCM is equal to, consider two positive integers may be A into B. In order to remember the formula. So HCF already he is given. HCF of 306 and 657 is 9. Into LCM we have to calculate. LCM means LCM of 306 and 657. So that it is equal to A means consider A is a number 306 into 657. 657. So therefore only LCM is equal to 306 into 657 divided by. So now divide. Why? By transposition method comes 9 comes inside the denominator. Now in the numerator you can multiply the given numbers. Okay. Now, so now divide 9 on the 9 7 the 63. 2 left 2 7 9 3 the 27. So that is why LCM of the given number is equal to 306 into 73. You can multiply and get the answer. 3 6 are 18. So 1 carry. 3 3 are 9. So 7 6 are 42. 4 2. 7 3 are 21. So add these numbers. 8. Right here. 8 3 13 2 2. Therefore LCM of these numbers, LCM of these two numbers is equal to, otherwise we may write like this also, 306 comma 657 it is equal to 22,338. So this is our required number. Like this we can find the given numbers. Now question number 5. Look here, check whether 6 to the power of n can end with the digit 0 for any natural number n. So try to understand the question. So yesterday I briefed about the definition about the fundamental theorem of arithmetic based on these examples. Yes, we know that if any number can ends with the 0, automatically it is divisible by 10. So that is why we should write first what is the number given here? 6 to the power of n. 6 to the power of n. And for n is any natural number. So for n is any natural number. So how it is possible digit becomes 0 for any natural number n? Yes. Observe carefully. If any number is divisible by 10 or its factors, that is 2 and 5, because 10 can be expressed as 10 is equal to 2 into 5 or 5 into 2. So if any number means natural number is divisible by 10 or its factors like 2 and 5, then it is contains the digit become 0. This condition applies because of the fundamental theorem of the arithmetic. Now express this number in the form of factors. Look here, 6 to the power of n can be expressed as 2 into 3, 4 to the power of n. Now what happened? The factors here 2 and 3 are prime factors such that I told already, if any natural number is divisible by 10, that is 2 and 5 also, then their number having the digit is 0. Means that number can end with the digit is 0. So look here this number having the factors like prime factors like 2 and 3, here at least 5 is not there. Instead of 10, 2 is there, 5 is not there. So therefore here factors 5 is not there, hence the 6 to the power, the given number is not divisible by 5. Therefore the given number the given number 6 to the power of n cannot be divisible by cannot be divisible by 5. Otherwise, this number cannot have the factor of 5. So that therefore 6 to the power of, for a given number 6 to the power of n cannot end with the digit 0 for any natural number. For any natural number. Clearly it says what happened. So if you check any number like 4 to the power of n, 5 to the power of n, 6 to the power of any number, if it is the prime factors are 2 and 5, then automatically it is divisible by 2 and 5 or 10. That is why it becomes there ends with the digit 0. Otherwise it is not possible to write their digit ends with the 0. That's why hence it is a solutions. So now we'll continue. Okay, now question number 6. Look here. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. You know already the meaning of the composite number. Composite number is nothing but the natural number which is divisible by 1 itself and other any number. So that is why that become composite number. Now here look here, all are prime numbers. Maybe some one are composite number. In order to get their product, if you express them in the factor, whether you agree composite number they are like that, they are asked the question. So now, first express them in the prime factor. So 7 into 6 into 5 into 4 into 3 into 2 into 1. I will take second one plus 5. Okay. So here observe here, this is the common factor. Try to use Boltzmann rule also. So 5 is common. Take 5 instead of the bracket. So now 7 into 6 into 4 into 3 into 2 plus 1. Okay. 5 into. So 5 into. So here why 5 is common? 5 can be divided by 5 means 5 cancel. So 7, 6, 4, 3, 2 and 1. Okay. Into 1 means we should neglect it. And plus 1 because it is divisible by 5, the remainder is 1. That is why equal plus 1. So now simplify. 7, 6 are 42. 42 into 4 into 4. Okay. 8. 16. 168. 42 into 4, 168 into 3. Into 3. 24. Okay. 6 3s are 18. 18 plus 2, 20. 2 carry. 3 1s are 5. Into 2. Okay. So 4 2s are 8, 0, 10. So you become 1008 plus 1. So now 5. 1008 plus 1, automatically it is 1009. If you apply the prime factorization method, you should not factor further. So that is why it can be expressed in some other number. Of course, it has some composite number. Means some prime numbers are also there, some composite numbers also there. So that is why clearly it is understood. 5 is a prime number, 1009 is also one of the number. So if you factorize it further, some composite number comes again, and further prime numbers also comes. That is why 1 is over. All this number 1. Now take the first one, this one. That is 7, okay, into 11 into 30 plus 30. Okay. Now here also we can take the common factor is 30. That is why 13 into 7 into 11 into, here plus is here, plus 1. So because 13 is common, I took here HCF of this number 13. So that is, for simplification, 13 is a common. So remaining number 7 and 11 plus 1, because 13 cancel 1. So now 13 into 11 7s are 77 plus 1. So that is 13 into 77 into plus 1, 78. Clearly, it is also by using this prime factorization method, we can express this number in the form of prime factors. But it involves the prime number, composite number also. That is why 13 is a prime number. Of course, 78 involves the some composite number. That is why this and this we should consider, including the prime factors. Totally, the numbers which would be expressed in the form of prime factors, we observe that the given numbers are composite number. That is why it is solution. So we conclude this one. The next and the last question in the exercise 1.2. Clear. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Okay, there is a circular path in a field. Sonia takes 18 minutes to around it, and Ravi takes 12 minutes to complete the around. Suppose they both start at the same time, at the same point and the same time, and go on the same direction. After how many minutes will they meet again at the starting point? Okay, so this is our question. You can go through the textbook also. So now solution. Consider first, Sonia takes 18 minutes to complete to drive circular path. Whereas Ravi takes 12 minutes to complete to drive circular path. So now comparison comes. So who took lesser time? The Ravi takes less time comparing to with respect to Sonia. Therefore, we should take there. So in order to get, if they start at the same time, with the same point, and after completing the around, at what time or on what time will they meet again? I mean, in which time they can meet again. So this should be we have to find. So in order to find that one, we can take the LCM, because so that around path is there now. One takes 18 minutes, another one person takes 12 minutes. So if you take the HCF, it become what happened? Common time. Okay, but it is not completed. If you take the LCM, that completes the around. The circular around is there now. That can be completed by the same members at the same time and same direction. So that is why LCM of the given time, that is 18 and as well as 12. Similarly, we can express by prime factorization. That is 6 into 3s are. This is called 4 into 3s are. Otherwise, you can express this into 2 into 3 into 3. Otherwise, you can express it into 2 into 2 into 3. So consider it. Which is the common LCM? Already it is written 2 into 3, 6 will become. So now we want LCM. Therefore, LCM means highest power. It can be expressed as 3 square. Here it is expressed as 2 into 3. So highest powers only we should consider. In a 2 square. In a 3, it is 3 square. Therefore, 2 square become 4 and 3 square become 9. Therefore, totally 36 minutes. So, whereas if they start together at the same point and the same time, while they are going the same direction, after 36 minutes, they meet again at the starting point. So, this is the required. Therefore, Ravi and Sonia meet again after 36 minutes. So this is your solution. Yes. So today I completed exercise 1.2 problems. In the next class I will continue revisiting the irrational number and the rational number and its decimal expansions. Thank you.